Good morning, class, and welcome to another interesting edition of my lessons on my YouTube channel. I am your lecturer, Dr. Peter Piahin, at the Department of Computer Science and Informatics in the University of Energy and Natural Resources. Today, we are going to talk about a very important component or aspect of computing, that is operating system. Basically, we will be looking at some of the introductory concept of operating systems, some history behind operating systems, some types of operating system, the advantages and disadvantages, and other things. So as I've been doing always, I'll share my screen with you, then we'll move on. But I want us to take a look at operating system as one of the main components of the computer. It's a typical example of a system software. If we want to take any computer, or when we talk about the components of a computer, we are basically talking about the hardware component and also the software component, or the system software. So the software, a typical example of a software component of the computer is the operating system, or the system is the operating system. So today we are going to look at the operating system as an example of a system software. So as usual, I'm going to share my screen with you so that we can continue. Okay, so let's look at some of the history of operating system. The first generation of operating system was around the 1940s. That is, the earliest electronic digital computers had no operating system. So around the 1940s, when the first generation of computers started, the electronic digital computers had no operating systems in them. That's the programming languages were unknown, not even assembly language. And the operating system was never heard of. In the 1950s, that is around the second generation of computers, the General Motors Research Laboratories implemented the first operating system in the early 1950s for their IBM 701 machine. The system ran one job at a time. These were called single stream batch processing system because programs and data were submitted in batches. Around the 1960s too, that is the third generation, the systems of the 1960s were also batch processing system. But this time they utilized computer resources by running several jobs at once. Another major feature in this third generation operating system was the technique called spooling, that is simultaneously peripheral operations online. Another feature was also time sharing techniques, and these systems were developed to multi-program large number of simultaneous interactive users. And the fourth generation, that is with the development of the large-scale integration circuit chips, operating system entered in the system, personal computer, and also the workstation age. In the 1970s, technology evolved to the point that it became possible to build desktop computers as powerful as the mainframe. Two operating systems have dominated the personal computer scene. That is MS-DOS, written by Microsoft in cooperation for the IBM computer and other machines using the Intel 8088 CPU. UNIX, which for computer using the Motorola 6899 CPU family. So these were the two operating systems that were dominating. Now let's compare Windows and Linux. We can say that Windows, if you have Windows, you have full access as compared to Linux with little access or no access. With Windows 2, licensing is also free. With respect to Linux licensing, there is a little bit restrictions on licensing. With Windows, there is support online, peer support, but with Linux, it's paid help desk support. With Windows 2, we have full support of the hardware as compared to Linux, which has partial hardware support. There is a command line in Windows, but there is no command line in Linux. Windows is also centralized, and Linux is non-centralized application installation. You can also have a lot of flexibility with respect to Windows. And but Linux, there is a lot of rigidity in it. The Windows, as I have put it, is for the fanboys. Windows is normally used by like any individual. It's easy to use, but for Linux, it is the corporate types. The Windows is also automated, and the Linux is non-automated removable media in terms of the media. And the Windows also is also a multi-layered or run a multi-layered levels as compared to a Linux which run a single layered level. Now let's look at the overview of operating system. An operating system is a program that acts as an interface between the user and the computer hardware and also controls the execution of all kinds of programs. It performs all the basic tasks such as file management, memory management, and process management, etc. Some popular operating systems include the Linux operating system, the Windows operating system, the VMS, the OS 400, the AIX, Z OS, and etc. So these are some of examples of operating systems. We are saying that the operating system basically acts as an interface, that is something in between the hardware and the user. And it also controls most of the important executions of the computer program. That is, it performs file management, memory management, also process management. So if you take a look at, if you conceptualize the OS as the hardware as a diagram, you can have the user, that's user one, someone using the computer one, another person using computer two, up to the nth person using computer. So this is basically the software aspect of the computer. And this is also the hardware aspect of the computer. So within the hardware, you can have the CPU, the RAM, and the various input and output devices, that is the peripherals. And in between, the operating system is part of the software, and it is normally found inside, or it is a component within the software. So within the software, you can have the system software and also the application software. The operating system serves as an interface in between the hardware. So this is the hardware, and this is also the software. So this is the operating system. If you look at the diagram, this is the operating system. So the operating system serves as an interface. It serves as a link between the hardware and the various softwares or the various system and the various softwares within the software environment. So this is the software environment. The operating system is also found within the software environment. And within the software environment, you can have the system software and also the application software. So the operating system serves as an interface. So it is the operating system that helps you, that aid you, the user, to even interact with the hardware component of the computer. The systems or the operating system serve as a background or serve as a foundation for you, the user, to interact with the hardware or to interact with the computer, basically. So this is just a simple diagram conceptualizing how the operating system interact with the hardware and how the operating system also interact with the user. So basically, the users do not normally interact with the hardware. They interact with the hardware through the system, through the software, that is through an operating system. Now let's look at some of the main functions of an operating system. There are a lot of them, but key among them is memory management. The operating system is responsible for memory management. That is how the system, it controls how the computer should manage its memory, I mean the RAM. Also process management, how it can control the various processes. Device management, how it can also control the various devices. File management, provide also security management, that was security. That is control over system performance, job accounting, error detecting aids, and also coordination between other softwares and the users. So these are some of the main functions of an operating system. One, it supports or it functions as a memory management, process management, device management, file management, security, control over system performance, job accounting, error detecting aids, coordination between other software and also users. Now let's look at some of the types of operating system. The first one is the batch operating system. That users of a batch operating system do not interact with the computer directly. That is, the jobs are prepared offline and processed in batches. These are some of the disadvantages. Lacks of interaction between the user and the job. Because the users do not normally interact with the operating system, there is this lack of interaction between the user and also the job. And the CPU is often idle because the speed of the mechanical input and output device is slower than the CPU. So most of the time, the CPU is what I would term as is not efficiently used, and the CPU is underutilized because sometimes the CPU can be idle because the speed between the input and output devices is slower as compared to the CPU. And it's also difficult to provide the desired priority. You cannot, in terms of priority, because the computer, as a matter of fact, sometimes works based on the priority principle. It gives priority to a lot of things in this operation. Now, we also have another type of operating system, that is the time-sharing operating system. This technique also enables many people at various terminals to use a particular computer system at the same time. Some of the advantages are it provides the advantage of quick response. It also avoids duplication of software and also reduces CPU idle time. So as compared to the batch operating system, the time-sharing operating system reduces the CPU idle time. So with this type of operating system, the CPU is not underutilized. It's not more underutilized as compared to the batch operating system. Disadvantage, that is problem of reliability, question of security and also integrity of user programs and also data, and also problem of data communication. Difference between the batch systems and also the time. Difference between the batch systems and also the time sharing is that batch systems are set to maximize processor use, whereas the time sharing systems are set to minimize response time. We also have another type of operating system, that is the distributed operating system. And with respect to the distributed operating system, they normally use multiple central processors to serve multiple real-time applications and multiple users. Processors in a distributed system may vary in size and also function. Let's look at some of the advantages of the batch, some advantages of the distributed system. With resource sharing facility, a user at one site may be able to use the resources available at another site. Speed up the exchange of data with one another via electronic mail or via If one site fails in a distributed system, the remaining site can potentially still continue operating. There is also better service to the consumers or the customers, reduction of the load on the host computer, and also reduction of the delay in data processing. So with this network operating system, this type of OS runs on a server and provides a server that capability to manage data, users, groups, security application, and other networking functions. Examples of such operating systems include the Microsoft Windows Server 2008, the Unix, the Linux, the Mac OS, and others. We also have advantages of the network operating systems. With respect to the network operating system, we have a centralized service, and the centralized servers are highly stable. Security is managed by the server. Upgrades to new technologies and hardware can be easily integrated into the system. Remote access to servers is possible from different locations and also types of systems. Let's also look at some of the disadvantages. High cost of buying and also running a server, dependency on a central location for most operations, and also regular maintenance and updates are also required. And we also have the real-time operating system. That is, it's a data processing system in which the time interval required to process and respond to input is small so that it controls the environment. That is the real-time aspect of the operating system. We are seeing that with this one, data processing, the time interval required to process data is so small that it controls the environment. We also have the hard real-time system. This system guarantees that critical tasks complete on time. A critical real-time task gets priority over other tasks and retains priority until the task is complete. We also have the soft real-time systems. That is, these are less restrictive and have limited utility than hard real-time systems. For example, multimedia, virtual reality, advanced scientific projects like the undersea exploration, and also planetary rovers. Now let's also compare these two types of operating. We have the single user operating system, and also that is in terms of classification, you can also classify operating system as being a single-user operating system and also a multi-user operating system. Let's look at some of the differences. In a single-user operating system, only one user can access the computer system at a time, while in a multi-user operating system, more than one user can access a computer at one time. A single-user operating system provides the facilities to be used on one computer by only one user. However, it may support more than one profile, while a multi-user operating system has facilities designed for more than one user to access the computer at one time. Generally, a network is laid down so that the computer can be remotely used. Thank you, and thanks for watching the video. This is just a short introduction to operating system. In our subsequent lectures, with respect to computer operating system, we'll be going into details. Thank you. Share the video, like it, and subscribe to my YouTube channel. Thank you very much.